All right, in this example, we're given the function as a graph, and we're asked to sketch a possible graph of the derivative of the function, and also estimate the value of the derivative at these points. So let's start with that, because if we have some points, then we can just plot points and connect them up. Um, so, uh, so that's the idea here. We're just going to estimate the value of the derivative at these various points. And in order to estimate the value of the derivative, what I'm going to do is just draw a tangent line, all right, and try to estimate the slope of that tangent line, and then use that as the estimate for the derivative at that point. All right, so I'm going to, first of all, we want to look at -2, right? So I'm going to try to draw a tangent line. Let's see how well I can do this. Ooh, no, that's what's going on here. I was trying to, all right, let's try that again. All right, so -2 is about there, and so I can draw a tangent line. And I'm just going to say that my estimate for the slope of that line is 5, right? You can see that it's positive. It's up, right? It's sloping upward as you go from left to right. So it's definitely positive. And I could pick a couple of points and say, okay, 1, 2, 3, 4, 5. So, it's somewhere around, I'm going to say it's somewhere around 5. Okay. All right. And then we can look at the next point. All right, so again, I'm going to take my little line tool and try to draw a line that's tangent to the curve at the point x equals -1. All right, so x equals -1 is right up here at the tippy top, so that one is actually pretty easy. I can actually draw a line like that. It's just going to be actually a horizontal line. And so what is the slope of a horizontal line? Right? There's no rise, and it's all run, so the slope is 0. All right, so the next point that we're going to look at is at 0, so we're looking at this point right here. So again, I can just sort of draw a line that's tangent to that point, and then estimate the slope of that line. Okay, so I've obviously done this previously, and so I'm going to estimate the slope of that line to be a -2. Notice it's negative because we're going down 2 and over 1, right? So it's a negative rise for a positive run. And so I'm just going to say -2. That's close enough. I don't have to be too accurate. It's hard. That's the hardest part, is just estimating the slopes, because it's hard to get a line that's perfectly tangent. But just do the best you can. All right, now let's look at the point x equals 3. All right, so that's this point down here at the bottom, and again, I'm going to have a horizontal tangent line, which means that the slope is 0. All right, we got one more point. That's for x equals 4, which is somewhere around here. And so let me use my line tool and try to draw a tangent line to that point. Okay, that's not very good. That's not a very good tangent line. Let me see if I can. All right, so something like that. And obviously I've done this previously, so I'm going to estimate that slope to be 5. Okay, so now I have a bunch of values. I have a table of values. These are my x values here, right? And then this is my f prime of x. So if I want to sketch a graph for the derivative of the function, I can just plot these points and connect them up. So I have the point -2, 5, -1, 0. I have 0, -2. I have 3, 0, and I have 4, 5. Okay, so I have some points. Now, this is actually going to, if you look at the graph here, you can see that if I were to draw a tangent line, say here, it's going to be steeper, and then it becomes more shallow. So the value of the derivative actually goes below this -2. So I'm just going to try to draw a curve between these points. Now it's going to continue downward, and then it's going to come back up. It looks something like that, okay? So there's a sketch of the graph of the derivative of a function. And you can see that the value of the derivative is positive wherever the function is increasing. And the value of the derivative is negative wherever the function is decreasing. And and then it's equal to 0 wherever we have that horizontal tangent, where it's basically, in this case, is where it's changing direction. All right, so that's where it's going to cross the x-axis. So that's one way to sketch the graph of the derivative of a function, but we don't have to get all of that specific about the actual values of the derivative in order to sketch the graph of a function. So in the next example, I'm going to show you how you can do it just by looking at whether the function is increasing or decreasing, and sketch a graph without getting all specific about the actual values of the derivative. All right, so I'll meet you in the next video.